Alright, so we're going to compare global and local maximums and minimums. This comes about, so what we've found so far in our teaching and our learning has been that we've been able to identify stationary points, and that's points where the gradient of a function is 0. So we can see, like, I'll talk about this question in a second, which is question 13, but we can see in this graph that there's two stationary points, and that function there is x cubed minus x squared. We can see that this point here represents a stationary point and this point here represents a stationary point. We can see that. Okay. So when we find the stationary points, we'll assign a value of max or min, but what we've been doing previously. But that's not what they actually are. Those things are local max and local mins. Now they may be the global max and min, but these ones are local max and mins, and we need to find out whether they are or are not the global. As you can possibly guess, the local max and min just points out that in this section of area here, the local area, that's the maximum point. Same as this one, in this area here, that's the minimum point. But if we were to look globally, we can see that this graph will continue to go down, which will make that not the minimum, and this function will continue to make that, to go that way, which will make that a maximum. So if I was to look at the entire domain, so the entire values of x, the global max and the global minimum is negative infinity and positive infinity. That's no good to us though. What we need to be able to do is to identify in a set domain what's our maximum and our minimum function. That's really important for identifying when we should do certain things, or how we can reduce or increase profits or reduce risk or that sort of stuff. Okay, so I've given us this question here, which is 13, and they've asked us to find they've only asked us to find the global max and the global min, but I'm going to find local, global for all sections of this graph. The function is y equals x cubed minus x squared, and this is really important. Probably, is it 4? I think it's 2. What's it got there for question 13? It is the 2. So this is really important. Okay, that's our domain, so that's no longer 4, that's now 2. I've made a very rough sketch of my function, and what I need to find out is what's my local, what are the max and min points. So the way I'd go about it, the way that I'd go about it is I'm going to look for a few key features. I want to find my stationary points, so things I want. Fast car, potato, so things I want are stationary points, so any of those, and I can see from the graph, but I've got 2, but I may not get a graph. So if I don't get a graph regardless, I want to find my stationary points, and I want to find values at border. I want to know what my value is here and here, because my graph might be wrong, I don't know. I want to find out if those values of y are greater or less than the stationary point values. Cool? Because every value between these 2 points, between that point and that point, I should know what's going on. Beyond those points, though, I need to find out. So I need to find my stationary points, and then I need to find what value of y I've got at my border, so I can identify whether I've got a local and a global max, or just a local max or a global max. Cool? Slash min. So I've got my function y equals x cubed minus x squared. I want to find my derivative of that, which equals 3x squared minus 2x. Okay. For our stationary points, I want that to equal 0. 0 equals 3x squared minus 2x. Okay. That obviously occurs when x equals 0, or if I take, I'll factorise that first, which means that I've got x out the front of 3x minus 2. So either x equals 0 or 3 minus 2 equals 0, which means that x equals 2 over 3. So they're my 2 stationary points. Great, I need to find the y value of those points and to find my coordinates. Okay, so I know this is important. I know that's important. Let's find my y values. I can identify whether they're max or min later. Probably should do that now, but I'm strapped for time. So I'm going to identify whether they're max or mins. I've just used a graph, but you know how to do that. Let's just assume that I've already done that. I want y equals 0 cubed minus 0 squared, which equals 0. And for this one, I want y equals 2 over 3 cubed minus 2 over 3 squared, and I get 8 over 27 minus 4 over 9, which equals 8 over 27 minus 12 over 27, which equals negative 4 over 27. Okay, so I now know that this value here on my graph, and I'll just show you that. I'll write down what I know. I know that this value here is 2 over 3, negative 4 over 27. And that's the important value, my negative 4 over 27, because that's my y value, which tells me whether it's a minimum or not. So I need to keep that value in check. I also need to keep my eye on this one here where I've got 0, 0. Okay. Now I've found my coordinates and my stationary points, I need to find my coordinates at the borders, because everything, whoop, that's pretty wild. Everything before the borders should be less than or greater than, depending on which direction. So I just need to look at my border values. So to find my border values, I simply sub my domain, so endpoint on the negative side, my endpoint on the positive side, into my function. So y, so I'm going to look at x equals negative 1 on 4 to start with. Y equals negative 1 on 4 to the power of 3 minus 1 on 4, negative 1 on 4 to the power of 2, which gives me negative 1 on 20, nope, that's 64. 64 minus 1 over 16, which gives me negative 1 over 64 minus 4 over 64, which equals negative 5 over 64. Okay, so I know straight up when I look at that, so I'll just highlight, I'll come back to that. I want to look at my top domain, so at x, I'll do that in a different colour. So I've looked at my negative border, now I need to look at my positive border. Wouldn't mind using a black pen. I'm going to let x equal 2. So x equals 2 now. Y equals 2 to the power of 3 minus 2 to the power of 2, which equals 8 minus 4, which equals 4. So let's come back to my graph. Over here, I'll lift this up. Head back to my graph. I know this value here. I wrote out what I want to know. We already know what I want to know. I know that this value here is equal to 2, 4. And I know that this value here is equal to negative 1 on 4, negative 5 over 64. So then from there, I need to find my global maximums. Let's first look at my global maximums. So the only two options for my global maximum are the point 0, 0 and 2 over 4. As I can see, this point here is higher. Even if I hadn't graphed it, I could look at my y value to see that. Okay. In this scenario here, I can see comparing those two values that clearly negative 4 over 27 is a bigger number than negative 5 over, negative 5 over 64. And I know what you're thinking, a big number doesn't make it more negative, but in this, it doesn't make it smaller, but because we've got negative values, this here is my local and my global minimum. So I've got and I'm going to put some titles on these. This is my global max. This is my global and local min. And this point here is my local max. And what that's saying is in that local area, that's the maximum value. But globally, in our domain, this is the biggest value. Our global and local minimum both occur at the same point. If I was to extend my domain negatively, that would no longer be the global minimum. Okay, there'd be a new global minimum somewhere down here, depending on where we set the domain. Cool. I hope that helps.